Welcome to Algebra 1, Semester 2, Unit 10, Section 8.5. In this section, we're going to look at exponential growth with model examples. Okay, so last section we were still looking at some linear. We'll do a little bit of comparison here. It says compare the linear function with the exponential function and fill out the t-chart and the formula. So let's just go right ahead and do that. We plug in -2 for x on this linear function and add 2. Pause the video and go ahead and do this. Okay, now we multiply that out. 3 times -2 is -6 plus 2 is -4. -3 plus 2 is -1. 2, 5, 7. When you come down here and graph this, I apologize that this graph is not a little more bold. But you can lightly see it because I'm using one of your copies. And I trust your eyes are a little bit better than mine. If not, you can put a piece of graph paper on here. Okay, so at -2, we're at -4. At -1, we're at -1. At 0, we're at 2. At 1, we're at 5. And at 2, we're at 7. I'm sorry, at 2 we should be at 8. That was a little mathematical error because 3 times 2 is 6 plus 2 is 8. The reason I caught it is because the slope would have changed on that last point. So, there is our function, linear function. Remember, linear means straight line. This came out as a straight line, so everything's in agreement there. Exponential function, because we have the variable in the exponent. Let's try that. 2 times 3 to the -2nd. Remember, with the negative exponent, we flip it to the bottom. So that becomes 2 over 3 squared, or 2 over 9. 2 times 3 to the -1st would be 2 over 3 to the 1st, or 2/3. 2 times 3 to the 0th. Anything to the 0th power is 1, so 1 times 2 is 2. 2 times 3 to the 1st. 3 to the 1st is 3. 2 times 3 is 6. 2 times 3 squared. 3 squared is 9. Times 2 is 18. So now when we graph this one, put our x-axis about the same height in each of these graphs. Okay. At -2, we are, let's make this our y. At -2, we are at 2/9, barely off of the 0. At -1, we're a little bit higher. At 0, we're up here at 2. At 1, we're clear up at 6. And at 2, we're clear off the graph. So we've got a curve going like that, which we've talked about exponential functions before that have that curve going. Okay, in the linear graph for each unit to the left of the axis, how many units did it rise? If we look over here to the left, it rose 1, 2, 3. 3 units. In the exponential graph for each unit to the left of the axis, how many units did it rise? Well, on the first one it rose gosh, just a factor of a third is what it is, or it's a factor of, I mean, we don't want to talk factors, it's less than 1. So less than 1 we could say, because both of these are a different fraction due to being a factor. How do the y values increase in each function? Okay, linear is constant. And exponential is a percent, we could say, percent or a factor there. Highlight where the numbers and the functions are revealed in the table. Let me grab a highlighter real fast. Okay. The 3, it's right there, it's the slope in the linear function, and that's what causes the lift of 3 over 1 down here in the graph. In exponential, the growth right there, that 3, is what causes this to increase by a factor of 3. Okay? So that's why it keeps getting larger, is as you go to the right, the numbers get larger and you're multiplying by 3. Next page. Determine if the given function is exponential or linear, and then write the rule to fit the function. Well, we notice on this one that the linear function is just simply adding 3 to each number. This one, it's being multiplied by 3. We've talked about that with sequences in the past, so we're really looking to see, is it multiplied or added to go to the next term. Here we could have times 2 or plus 2, but here that's definitely a times 2. Oh, I'm sorry, it said times 2, wrote times 4. Times 2, times 2, times 2, and times 2. So the type of function would be exponential. Now it says to give the rule. If we look back at the last page on that graph, where the times 3 came in was right there in that value. This 2, we actually only see, the beginning 2 we see on the 0 line. That's where we get the first number. So if we go over here, our 0 value is 8. Our growth factor, or how much it's getting bigger by, is our common ratio is 2, and then we just put the x. Okay? Next one. Again, we're looking to see if it's adding or multiplying. 2 to 4 would be add or multiply, but then 4 to 6 would be add. So now we're adding on this one. 6 to 8 would be add 2, 8 to 10, add. It has to be a rule that works for all. So this type would be linear because it was adding. That would be a straight line if we graphed it. The rule, remember, the growth there is attached to the x. That's what we saw back here on this linear function. And then look at where this 2 shows up. It shows up just like with exponential at the 0. That's our y-intercept. So here we go. Our 0 value is 6, so it would be plus 6. Okay. Next one. It goes from 3 to 6. That could be plus 3 or times 2. Then it goes 6 to 12, so we can see it's times 2. Make sure it works for every number. 12 times 2 is 24. 24 times 2 is 48. So our rule is it's being raised by 2. Now our 0 value is 12, so we go 12 times 2. And that's an exponential. Turn off the video at this point and do this fourth one and then turn it back on. I'll have the answer in here. What might have stumped you on this one was over in this section where it had a fraction and another fraction. But if we come over here, we can see -3 times 2 is -6. -6 times 12, or times 2 is -12. So now we have to ask ourselves, does this work here? Well, if we multiply that by 2, remember, we'd reduce it and we would get the -3. And if we multiply this one by 2, again, we would reduce it and we would get -3/2. Okay? On the next page, I want you to graph each of these functions and highlight where the numbers in the function are revealed in the graph, just like what we did on this previous page, where we had these highlighted and showing the graph down below, showing where it shows up there. I want you to do that for these functions on the back side here. So the very first one I'm going to do with you, and then you're going to do the other 3 on your own, either in class or right now. So the number 1, first one, was 8 times 2 to the nth. That's the rule that we got. I think that I'd need to count by 2's. 4, 6, 8. So right here would be my 8. That's at 0, 1. And then at -1 I have 4. And at -2 I have 2. So you can see the curve. Each one going to the left is getting half as tall as the one before. Going to the right, it's twice as tall. So this one would be clear up there. And we get that nice exponential curve with that. Okay? You can actually take the points right off of your previous page and graph them on this page. Okay? I want number 2 here, number 3 here, and number 4 right here when you come to class. And then we'll be working on a couple lab things and this bookwork. Have a great day. We'll see you tomorrow.